All right, on the next example, example 8, this says a mountain cabin is built on the side of a hill with a porch extending over a portion of the downhill slope. Nice. Okay, an observer 20 feet downhill from one leg of the 8-foot vertical support beams measures the angle formed from the top of the beam to the bottom of the beam to be 10 degrees. Okay, so in this little triangle that is formed here, the angle down here is the 10 degrees. Okay, now we're going to be looking at this triangle in here. The little bitty angle down there is 10 degrees. The side opposite it is 8. What they want us to know, okay, or find out for them, is what is the angle of inclination of the hill to the nearest 10th of a degree. So how steep is the hill? What is that? Okay, so what we are actually looking for is how steep is this hill? Let's draw straight across vertical, that would be horizontal. And then let's drop a vertical straight down here. What they're wanting us to find is let me kind of make this in red because it's going to be our final answer here. What is this angle here? Okay, that is actually going to be the angle of inclination of the hill. Remember, angles of inclination and angles of depression are always measured with respect to the horizontal. Okay? All right. Well, let's see. In that right triangle, okay, we're trying to find this angle here, okay, this angle of inclination in that right triangle, and all we know is that the hypotenuse of that right triangle is 20 feet. Okay, that's the hypotenuse. So we really don't have enough information. We need one other leg length maybe, or we need another angle. Another angle would be nice. Okay, so what we could do is, since we know that, concentrate on the blue kind of looking triangle. That looks to me to be like a blue obtuse triangle. We have this angle, whoops, I meant to use blue. We have this angle 10, opposite side 8. And we have this side here is 20. And so that could allow us to find that angle up here by using law of sines. Okay? So we could say that the sine of 10 degrees is to its side opposite, that is 8 feet, as the sine of that missing angle. I don't know what we'll call it. We'll call it angle A. Why not? Okay. The sine of angle A is to its side opposite, 20 feet. Okay. Now, when we multiply both sides by 20 to clear out our fractions, okay, we're going to have the sine of angle A. I would like to kind of go ahead and reduce right here by 4. 4 will go into 8 2 times. 4 will go into 20 5 times. And so I can have 5 times the sine of 10 divided by 2. Or what's equivalent to that, 5 over 2, is that's 2.5. I just think that that would be easier to punch into my calculator, okay? If you take 20 divided by 8 or 5 divided by 2, that's where I got that 2.5. I just think that's easier to punch into the calculator. Okay, ultimately I'm trying to find what is angle A. So to get the sine off of there, I'm going to take inverse sine of both sides. So I'm going to find what angle has a sine value of 2.5 times the sine of 10 degrees. Okay, that'll give me angle A. That's really all I could do. Hopefully that will lead to something fruitful to be able to solve the rest of this problem. Okay, but for now, let's just punch that in. Okay, I'm going to say what angle has a sine value of 2.5 times the sine of 10 degrees. Close out the 10 degrees. Okay, close out the 10 degrees, close out the other one, the other parenthesis. And that angle, angle A, is 25.73, okay? 25.73, that looks pretty good. Okay, this angle right here is 25.73. All right, now, well, we don't have enough. Do we have enough? No, we don't have enough information to use the big right triangle that I'm seeing there. So here's what we should do, okay? Next, let's find this angle right here, okay? That angle up there in that blue triangle, that third angle, I don't know what we should call it, maybe angle C, I don't know, okay? Angle C is going to be 180 less the 25.73 less the 10 degrees, right? Let this angle and this angle taken off of there. And so that angle is 144.27 when you subtract that. So that's 144.27. So if we know that, then let's see, what color should we use? That's the important question that needs to be answered. Okay, then we know that this angle, and this is a straight segment right here, okay? And so we know that those two angles are supplementary. And so this angle up here, maybe I'll call it theta. I don't know. Theta is going to be 180 less the 144.27. Okay, that's going to leave us with 35.73 degrees. 35.73 degrees. Okay, and so what we've got here, y'all, if you notice, we have a right triangle right in here. Okay, we have one of the angles of the right triangle, and the other angle that we're looking for is going to be complementary to that, right? Okay, those are going to add up to be 90 degrees. So the angle of the inclination of the hill is going to be 90 degrees minus 35.73. Okay, rounded to the nearest tenth of a degree will be 54.3 degrees. That's the angle of inclination of the hill that we were trying to find. Okay, so we had to work through a lot of steps there. Okay, but hopefully all of that will make sense to you. Now, here's a little point of interest. Okay, you can read through here. What is the Haversine function? Read through that if you want to. Okay, and then let's move on. To apply the law of sines, an angle must be given and a side opposite or adjacent to the given angle must be given. We've got to get a pair. And so if we have an angle given, we need the side opposite that angle to also be given. So it says, in which cases can the law of sines be used to solve a triangle? Okay. Angle, side angle. Side angle, angle. When you're given two angles, you can find the third one really easy, okay? And then also this case, the ambiguous case. Okay, now number 3, it says to suppose that triangle ABC has sides length ABC and opposite angles ABC, respectively. Write the law of sines. Okay? I like this form. The sine of angle A is to side A as the sine of angle B is to side B. And then we're going to extend the proportion to cover all the possibilities. The sine of angle C is to side C. Now, you could also use the reciprocal of all of these. If you flip one, flip them all. Okay, and that's another form for our law of sines. Okay, number 4 says, suppose that the lengths of two sides, A and B, in a triangle are known, along with the measure of angle C between those. We've got side, angle, side case. Okay? Then the area is given by 1/2 times the product of the two sides, A times B, times the sine of the angle between those, sine of angle C. That's one way that you can find that area. No, that's how you need to find that area, given that information. All right, number 5 says, suppose that we know the measure of angle A and the lengths of sides A and B of a triangle. If A is greater than B, how many possible triangles can be formed? Okay, let's see. If A is greater than B, oh, I didn't write that down. You know, if A is greater than B, let's go find that out. Okay, A is opposite angle A, and if A is greater than B, okay, let's go back and let's see. If A is greater than B, I don't know, I can't remember all those cases. I just kind of write them out. Okay, we were given angle A, and if A is greater than B, one triangle is possible. Okay? A is opposite given angle A, and if A is greater than B, then we've got one triangle possible. Okay? So, all this scrolling just to say one triangle possible. Suppose we know the measure of angle A and the lengths of sides A and B. If side A is less than B, but greater than the height, okay, we could have two triangles that would be formed. That was that other case where side A is less than B, but greater than the height, that's the height of that triangle, then two triangles are formed. And what we're talking about there is the case, blah, 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 back you back. One more. Yeah, right here. Okay. The height we saw when we were talking about the area can be figured as B times the sine of angle A. That's what the problem said here. B times the sine of angle A. That's the same thing as the height. Okay? We could have two triangles that are possible. All right, so in 7.2, it's the law of sines. Let's do that homework. Work as much of it as you can by next time. Okay.